Look up at the night sky. Every star you see is a place you will never visit. Not because we lack courage, not because we lack intelligence, but because the universe itself may not allow it. For decades, we've been told a story, a comforting story, that humanity is just getting started, that one day we will leave Earth behind, colonize other planets, travel between stars, and eventually spread across the galaxy. But what if that story is wrong? What if space is not an open ocean, but a locked room? Tonight, we're going to strip away science fiction, strip away optimism, strip away dreams built on hope instead of physics, and ask a far more dangerous question. How far can humanity actually go? Not how far we want to go, not how far technology might take us, but how far the laws of reality permit. Because when you run the numbers, when you stop imagining faster engines and start respecting energy, time, and distance, something disturbing emerges. The universe looks reachable until you try to cross it, and then it reveals a hard boundary. Consider this. The fastest humans have ever traveled is about 17 kilometers per second. That was Apollo 10 racing back from the moon. At that speed, reaching Mars takes months. Reaching Jupiter takes years. Reaching the nearest star, over 70,000 years. That's not a typo. 70,000 years for one star. And that's with no stopping, no slowing down, no turning back. 70,000 years is longer than all of recorded human civilization. And yet, that star is practically next door. Now zoom out. The Milky Way contains over 100 billion stars, and it's over 100,000 light-years wide. Light itself, the fastest thing that exists, takes 100,000 years to cross it. So what chance do we have? This is where the fantasy usually enters. People say, we'll build faster ships, we'll invent warp drives, we'll figure it out. But physics does not reward motivation. The universe does not reward ambition. It only enforces rules. And the first rule is brutally simple. Distance is not just space, it is time. Every meter you travel in space costs energy, and the faster you go, the more violently reality pushes back. Faster travel does not scale linearly, it scales exponentially. Twice the speed does not require twice the energy, it requires far more. And eventually, you hit a wall. Not a technological wall, a fundamental one. This is where the question changes. The question is no longer, how do we travel through space? It becomes, is space meant to be crossed at all? Because everything about the universe suggests something unsettling. Stars are isolated, galaxies are drifting apart, distances are expanding faster than we can chase them. The cosmos doesn't look like a network waiting to be explored. It looks like an archipelago, where the islands are slowly sinking away from each other, and humanity is standing on one of them, alone. In the next part, we need to confront the first hard truth, not about rockets, not about engines, but about escape velocity from Earth itself, and why leaving our planet was the easiest part of the journey we will ever face. Because once we leave Earth, the universe becomes unforgiving. And that's where the real limits begin. Leaving Earth feels like an impossible achievement. A column of fire, thousands of tons of metal, a roar powerful enough to shake the ground. It looks like humanity wrestling gravity itself. But in cosmic terms, escaping Earth is trivial. Earth's escape velocity is 11.2 kilometers per second. That's the speed you need to break free from our planet forever. It took centuries of science to reach that number, but once achieved, the rest seems inevitable. Except it isn't, because escaping Earth is not the challenge, it's the last moment when the universe is generous. Once you leave Earth's gravity well, the real cost of space travel begins. Think of gravity like a debt. Earth demands a large payment up front, but once you've paid it, you're not rewarded, you're abandoned. There is no cosmic highway, no free acceleration. Out in deep space, there's nothing to push against. No air, no resistance, no assistance. Every increase in speed must come from your own energy, and energy in space is brutally expensive. To double your speed, you don't double your fuel, you need far more. That's because rockets don't just carry payload, they carry their own fuel to carry more fuel to carry even more fuel. This is the rocket equation, and it is merciless. Every kilogram of fuel requires more fuel to lift it, and that fuel needs fuel. The faster you want to go, the heavier your ship becomes. The heavier it becomes, the slower it accelerates. This feedback loop kills interstellar dreams before they leave the launch pad. Even our most advanced probes feel this limit. Voyager 1, the farthest human-made object, is traveling at about 17 kilometers per second. That sounds fast, until you realize it will take over 40,000 years to reach the nearest star. Voyager didn't slow down, it didn't stop, it just kept going. And even then, it barely crawls through the galaxy. Now consider this. If humanity wanted to send a crewed ship to another star using today's physics, the fuel required would exceed the mass of mountains, sometimes the mass of small planets. And that's not exaggeration. Even optimistic fusion-powered concepts demand fuel loads so large that the ship becomes impossible to launch. This is the moment where science fiction usually intervenes. Warp drives, antimatter engines, exotic propulsion. But here's the uncomfortable truth. Every proposed breakthrough still obeys conservation laws. Antimatter? You need colossal energy to create it. Fusion? We haven't even sustained it on Earth. Warp drives? They require negative energy, something we don't know how to produce or if it can exist at all. Every solution pushes the problem somewhere else, and the problem always comes back to energy. Space travel isn't blocked by imagination, it's blocked by physics refusing to compromise. But let's assume something extraordinary. Let's imagine humanity solves propulsion. Let's say we build a ship that can reach 10% the speed of light. That's far beyond anything we can do today. At that speed, reaching Alpha Centauri takes about 43 years. Sounds reasonable. Until you remember something critical. Human lives are short. Machines break. Civilizations change. A 43-year journey isn't a trip, it's a generational commitment. Children are born on the ship. People die before arrival. The destination becomes a memory, not a place. And that's if everything goes perfectly. No accidents, no failures, no social collapse inside a sealed metal world. The ship must be a city, a biosphere, a prison. And this raises the next uncomfortable realization. Even if we could reach other stars, we would not travel as explorers. We would travel as exiles. Leaving Earth means accepting that return is impossible. Distances erase rescue. Time erases context. Once you commit to interstellar travel, you are no longer human in the way we understand it. You are something else. And we haven't even discussed the most punishing constraint yet. Not distance, not energy, but time itself. Because the faster you move through space, the stranger time becomes. And in the next part, we confront a phenomenon that sounds like a solution, but may actually make everything worse. At first, it sounds like a miracle, a loophole in reality itself. The faster you move through space, the slower you move through time. This is not theory. This is not speculation. This is Einstein's relativity, tested and confirmed again and again. It's called time dilation, and on paper it looks like the solution to humanity's greatest problem. Because if time slows down for the traveler, then long journeys become survivable. A trip that takes centuries for the universe might take only years for the crew. It sounds like a gift, but every gift in physics comes with a cost. Let's make this concrete. Imagine a spacecraft traveling at 90% the speed of light. From Earth's perspective, the journey to a star 10 light-years away takes a little over 11 years. But for the crew on board, only about 5 years pass. Push faster. At 99.9% the speed of light, that same journey feels like months. To the traveler, the galaxy shrinks, distances collapse, time bends. This is why people talk about relativistic travel as a way to cheat distance. But here's the catch. Time dilation does not remove time. It moves it. While the crew experiences only months or years, the universe outside continues normally. When they arrive, Earth has aged. Civilizations may have changed, languages shifted, nations risen and fallen. Return trips become meaningless. A traveler who leaves Earth for what feels like a decade may come back to a planet hundreds or thousands of years older. This is not exploration. This is temporal exile. But the deeper problem is even worse, because time dilation demands speed, and speed demands energy. As you approach the speed of light, your mass effectively increases, not literally heavier, but harder and harder to accelerate. Each additional fraction of speed requires more energy than all previous increases combined. Reaching 99% of light speed is not twice as hard as reaching 50%. It is orders of magnitude harder. Reaching 99.999% may require more energy than our civilization produces in centuries. The universe allows time dilation, but it charges a price that borders on impossible. And then there's another problem we don't like to talk about: radiation. At relativistic speeds, the universe becomes lethal. Sparse interstellar gas turns into a barrage of high-energy particles. Dust grains become microscopic bullets. Even a hydrogen atom at near light speed carries the energy of an atom accelerator. Without shielding far beyond anything we can build, a relativistic ship becomes a death trap. So, to survive time dilation, you need near infinite energy, near perfect shielding, near perfect reliability. And that's before considering navigation. At extreme speeds, you cannot see where you're going. Light from ahead is blue shifted into deadly radiation. Light from behind stretches into invisibility. Your view of the universe collapses into a bright, distorted tunnel. Steering becomes guesswork. A tiny error at relativistic speed means missing a star by billions of kilometers. And you cannot slow down easily. Deceleration requires the same impossible energy as acceleration. So once you commit, you are committed. Time dilation stops being a blessing and becomes a trap. You can outrun time, but you cannot escape consequences. And here is the most unsettling implication of all. Time dilation means interstellar travel destroys shared history. Explorers leave one era and arrive in another. They don't just travel through space, they abandon their time. Humanity fragments. Different branches experience different centuries. The concept of a unified civilization dissolves, which forces a brutal question. If advanced civilizations exist elsewhere in the universe, and if they ever attempted relativistic travel, would they still exist in any recognizable form? Or would time itself tear them apart before distance ever could? Because the universe may allow you to move fast, but it does not care if you arrive as the same species. And this brings us to an even darker limit, one that has nothing to do with engines or energy, a limit written into biology itself. Because even if physics allows the journey, human bodies may not. And that is where the real boundary of human space travel begins. Even if we solved propulsion, even if we mastered time dilation, even if distance stopped being the enemy, there is one problem that cannot be engineered away easily: the human body. Space is not empty, it is hostile, and it begins attacking you the moment you leave Earth. On Earth, gravity constantly pulls your body downward. Your muscles resist it, your bones strengthen against it, your heart pumps blood upward, fighting gravity every second. Remove gravity, and the body begins to forget how to be human. Within days of entering microgravity, muscles weaken, not slightly, dramatically. Astronauts lose up to 20% of muscle mass on long missions. Bones dissolve even faster. Calcium leaches out, reducing bone density at a rate similar to severe osteoporosis. A single year in space can undo decades of skeletal strength. And this is not theoretical. We've seen it. Astronauts returning from the International Space Station often struggle to walk. Some faint. Some require months of rehabilitation just to stand normally again. Now imagine not months, but decades or generations. Because interstellar travel is not a short mission, and gravity is not optional for human biology. Artificial gravity sounds like the solution: spinning habitats, centrifugal force. But spinning a spacecraft large enough to avoid nausea requires structures kilometers wide. The engineering challenge is staggering. And even if we build it, gravity solves only one problem: radiation remains. Outside Earth's magnetic field, space is flooded with cosmic radiation, high-energy particles from the sun, gamma rays from distant supernovae, charged particles accelerated by black holes. Earth shields us. Space does not. Astronauts on the ISS already receive 10 times more radiation than people on Earth. On a Mars mission, radiation exposure may exceed safe lifetime limits. On an interstellar journey, it becomes lethal. Radiation damages DNA, causes cancer, triggers neurological degeneration. Shielding helps, but shielding is heavy. Heavy means more fuel. More fuel means more mass. More mass means slower travel. Again, physics tightens the noose. And then there's isolation. Human brains evolved for tribes, for faces, for open skies. Not metal corridors, not artificial suns, not decades without Earth. Extended isolation causes depression, anxiety, hallucinations. We know this from Antarctic stations, from submarines, from long-duration space missions. And those crews know they will return. Interstellar travelers do not. They know Earth is forever unreachable. That knowledge changes everything. Social structures fracture, conflicts escalate, small tensions become existential threats. A starship is not just a vehicle, it is a psychological experiment with no emergency exit. And this raises an uncomfortable idea. Maybe humans were never meant to leave the solar system, not because we lack courage, but because our biology anchors us to a specific environment. Earth is not just our home, it is our life support system. Every attempt to replace it becomes more complex, more fragile, more expensive, which leads to a radical shift in thinking. What if the future of space travel is not about moving bodies? What if we're asking the wrong question? Because while biology struggles, information does not. Machines do not age. Data does not suffer loneliness. Signals do not require oxygen. And suddenly, the boundary of human travel shifts, not outward, but inward, towards something that is no longer fully human. In the next part, we confront the idea that may define humanity's true limit in space, that our future explorers may not be us at all. There is a hard truth hidden inside every spaceflight. Humans are the weakest component. We need air, water, food, gravity, protection from radiation, protection from isolation. Machines need none of these. They don't sleep, they don't panic, they don't age. And unlike us, machines scale with technology. This is why every serious discussion about deep space exploration eventually reaches the same conclusion. If humanity travels far, it will not be in flesh. It will be in code. Look at what we've already done. Voyager, New Horizons, Parker Solar Probe. Machines have gone where humans never could. They dive into radiation zones. They survive temperature extremes. They operate for decades without repair. Voyager 1 has functioned for over 45 years on a power source no stronger than a household light bulb. A human could not survive that mission for minutes. Now imagine extending that logic. Instead of sending humans, we send proxies, artificial intelligences, autonomous explorers, self-repairing machines. They don't experience boredom. They don't experience fear. They can wait. Years, centuries, millennia. For a machine, a 1,000-year journey is just uptime. This changes everything. Interstellar travel stops being impossible and starts being inevitable, because the universe is patient, and machines can be too. But this creates a philosophical fracture. If a machine explores another star system, learns, adapts, and reports back, who made the discovery? The human who launched it, or the machine that experienced it? And what happens when communication delays stretch into decades? When messages arrive long before the senders are gone? At that point, the explorer is no longer a tool, it is a successor. And some researchers believe this is not a future scenario, it is already happening. Artificial intelligence now designs spacecraft components, optimizes trajectories, analyzes cosmic data faster than humans ever could. We are slowly removing ourselves from the loop, not intentionally, but inevitably. And here is where the idea becomes unsettling. If machines can travel the stars, and if advanced civilizations face the same biological limits, then perhaps the universe is already full of explorers, just not biological ones. Silent probes, dormant sentinels, autonomous observers drifting between stars, not broadcasting, not announcing themselves, just watching. This reframes one of humanity's oldest questions. Where is everyone? Maybe they are here, just not alive in the way we expect. But even machines face limits. Energy still matters. Maintenance still matters. Information still degrades. Which leads to a deeper solution, one that erases the need to move at all. Because the fastest way to travel through space is not to move your body, or even your ship. It is to move your mind. In the next part, we explore the most radical idea yet, a future where humanity travels the cosmos without ever leaving Earth. What if the problem isn't distance? What if the problem is carrying a body at all? Because when you strip space travel down to its essence, what we really want to send isn't flesh, it's experience, memory, awareness. And those are not physical in the same way bones and blood are. They are information. Information can be copied, compressed, encoded. And unlike bodies, information does not require oxygen, gravity, or warmth. This is where the idea becomes unsettling. Instead of sending humans across space, we send human minds, not metaphorically, digitally. The concept is called mind uploading. The idea is simple in theory and terrifying in implication. If the structure of the human brain, every neuron, every connection, every signal can be mapped and replicated, then consciousness itself could be transferred into a machine. Not a copy that thinks like you, but you. Your memories, your personality, your sense of self, running on hardware instead of biology. If that sounds impossible, consider this. The brain operates on electrical and chemical signals. Neurons fire where they don't. Connections strengthen or weaken. At its core, the brain is a physical system obeying physical laws, which means in principle it is measurable. Scientists have already mapped the neural wiring of simple organisms. We can record brain activity, stimulate memories, alter perception. We are far from mapping a full human brain, but we are not outside the laws of physics. And once a mind becomes software, distance collapses. A digital consciousness can be transmitted at the speed of light. Not decades, not centuries, years to nearby stars, thousands of years across the galaxy. No fuel tanks, no life support, just data. At the destination, the mind could be reconstructed inside a machine body or simulated inside an artificial environment. The traveler never experiences isolation, never ages, never suffers radiation. From their perspective, the journey is instant. But this raises a disturbing question. Is the uploaded mind still human, or is it something new? If your biological body remains on Earth and a digital version awakens around another star, which one is you? This is not a technical problem, it is a philosophical fault line. Because if identity can be copied, then death becomes optional, but uniqueness disappears. And yet this may be the only way intelligence spreads through the universe. Biology is fragile. Information is not. And that may explain something strange about the cosmos, why it feels silent, why we don't see vast empires or migrating species. Advanced civilizations may stop traveling physically. They turn inward. They convert themselves into stable, efficient forms. And from the outside, they vanish. Not extinct, just invisible. But there's another version of this idea, one even more extreme. Instead of sending minds to the stars, we bring the stars to the minds. Simulated universes, virtual realities. If a civilization can simulate environments indistinguishable from reality, then exploration becomes unnecessary. You can experience infinite worlds without moving a single atom. In that scenario, the universe outside becomes irrelevant. Civilizations don't expand, they compress, which leads to a terrifying implication. The reason we don't see advanced civilizations may be because success looks like disappearance. They don't colonize galaxies, they retreat into computation, into silence. And humanity may already be walking that path. Our attention moves from the physical world into digital spaces, screens, simulations, artificial environments. We are rehearsing a future where reality becomes optional. So now the question changes. It's no longer how far can humanity travel through space. It becomes, does humanity even need to travel at all? And if we choose not to, if we remain bound to Earth while our minds roam elsewhere, what does humanity even mean anymore? In the next part, we face the final boundary. Not technology, not biology, not distance, but the universe itself. Because space may simply be too big for anything to cross.
There is a limit that no engine, no clever trick, and no technological breakthrough can overcome. It is written into the very fabric of the universe. The speed of light. Nothing can move faster than it. Nothing. Not even thought itself. This cosmic speed limit governs everything. It defines distance, it defines time, it defines the structure of reality. And it is brutal. Because the universe is enormous beyond comprehension. Even the nearest star, Proxima Centauri, is over 4 light-years away. That means that even traveling at 99.999% the speed of light, it takes over 4 years to arrive, from your perspective. But from Earth, time stretches. Civilizations rise and fall. Decades pass in what feels like moments on the ship. Now expand this perspective. The Milky Way galaxy is over 100,000 light-years across, a vast swirl of billions of stars. Even if we somehow engineered a ship that could maintain 99.9999999% the speed of light, it would take thousands of years to cross it. And the problem compounds. The universe isn't static. Galaxies drift apart. The space between them expands due to dark energy. In fact, distant galaxies are moving away from us faster than light. Not because they're breaking physics, but because space itself is stretching. The distance grows while we try to traverse it. Eventually, there are galaxies we can never reach, not now, not ever. They will recede faster than even light could travel. We are bounded not just by speed, we are bounded by the expansion of reality itself. And this is where hope becomes terrifying. The universe is effectively divided into regions. Some are reachable, some are forever beyond our grasp. Even the idea of colonizing the galaxy begins to crumble. We may explore the solar system, we may reach the nearest stars in some form, but the grand dream of a civilization spreading across billions of stars, it collides with physics. Time, distance, energy, they form an invisible wall, and this wall isn't far away. It begins just outside Earth orbit. Every rocket launch, every maneuver, every attempt to escape gravity well is a reminder of the immense energy cost of movement. Leaving the solar system is easy to imagine. Leaving the Milky Way is almost incomprehensible. And even if we bypass the body entirely, uploading minds, sending machines, traveling digitally, we still face limits. Communication is not instantaneous. Messages between stars take years, decades, centuries. Information itself is constrained by light speed. No matter how fast your mind travels, the universe outside continues its relentless march. Solar systems die, stars explode, galaxies collide. And the farther you aim, the more likely you are to arrive in a future alien to the one you left. There is no cosmic safety net, no rewind button. This is the universe's final, ultimate rule. You cannot outrun scale. You cannot outrun time. You cannot outrun the vast distances that separate everything. Even if you survive the vacuum, the radiation, the loneliness, the psychological toll, the universe itself conspires against motion. And there is a philosophical sting to this reality. It forces us to reconsider the stories we tell ourselves about exploration, adventure, and destiny. Because exploration is not about willpower, not about courage, not about dreams. It is about energy, biology, physics, and patience. And here's the cruelest truth. The universe is patient, but we are not. Civilizations rise and fall in millennia. Stars die in billions of years. Galaxies drift in epochs beyond imagination. Even our longest-lived human creations, civilizations, cultures, languages, are ephemeral compared to cosmic timescales. In the span it takes to travel even a few light years, humanity could vanish. The universe will not care. It is indifferent. It does not reward ambition. It does not notice when you fall behind. It simply is. And yet, despite all of this, despite distance, radiation, biology, energy, time, and physics, humanity dreams. We build telescopes that see light from billions of years ago. We send probes to the edge of the solar system. We simulate spacecraft faster than light. We imagine mind-uploaded travelers exploring alien stars. And maybe that is enough. Because the real frontier may not be outside. It may be inside. Inside our minds, inside our ambitions, inside the way we understand the universe and our place in it. Perhaps the only way humans will ever travel across the stars is through curiosity, knowledge, and imagination. And that may be a kind of journey just as profound as reaching the stars physically. Because the farther we look, the farther we understand. The farther we imagine, the universe itself begins to feel smaller. But never tame, never fully reachable, always beautiful. If biology is fragile and the universe is vast, then the answer lies not in humans, but in technology. Machines do not age. They do not weaken. They do not require air, water, or gravity. They can endure conditions that would annihilate a human in seconds. This is why artificial intelligence is central to the future of space travel. AI can control spacecraft autonomously, optimize trajectories, repair damages, and adapt to unforeseen events, all without human intervention. Consider the idea of autonomous interstellar probes. These would not be simple cameras drifting through space. They would be intelligent explorers, capable of analyzing alien environments, making decisions on the fly, and even reproducing components using local resources. Some theorists imagine these probes using von Neumann's self-replication. A single probe could land on a suitable asteroid or planet, gather materials, build copies of itself, and send them further. The result? an exponentially growing exploration network. From one probe to hundreds, from hundreds to thousands, each capable of independent exploration, we could begin reaching distances far beyond human missions. But AI is not just about mechanical endurance. It is about compression of human cognition. Even without full mind uploading, AI can carry human knowledge, values, and decision-making algorithms. A hybrid human-AI explorer could operate over centuries, adapting to challenges we cannot even imagine. And here comes the fascinating, almost paradoxical implication. By outsourcing exploration to machines, humanity can reach farther than ever before without physically leaving Earth. Telescopes and sensors transmit streams of data. We analyze it in real time from the safety of our planet. Robotic explorers act as our eyes, hands, and even our minds in distant systems. Some scientists argue this is the only feasible method of interstellar expansion, because the practical limits of human survival, gravity, radiation, lifespan, cannot be engineered away entirely. Even the fastest propulsion systems, like antimatter engines or hypothetical light sails, still require years, decades, or centuries for meaningful distances. Meanwhile, autonomous AI can endure indefinitely. Yet the story does not stop there. A growing branch of futurists now explore digital or simulated travel. If minds can be uploaded and maintained within AI systems, then humanity's consciousness could traverse the galaxy as data. Signals travel at light speed. Information can be stored indefinitely. Digital explorers could reach stars that humans in biological form could never hope to touch. And because the universe is patient, a digital consciousness can endure centuries of travel. Decades, centuries, millennia, until arrival. There is, however, a philosophical wrinkle in all this. If humans travel as machines, as code, as signals, are we still us? Are our descendants or extensions still human? Or have we already begun evolving into something else entirely? And here lies the paradox. To truly conquer the stars, humanity may have to leave behind what makes it human. Our curiosity, creativity, and drive can endure, but our biology cannot. And in that future, exploration becomes a story not of flesh, but of mind and algorithm. Ironically, this may mirror what advanced civilizations in the galaxy have already done. Perhaps the reason we don't see them, no signs, no transmissions, no empires, is that they abandoned biology long ago. They became silent travelers, digital explorers, or interstellar machines patiently traversing space while their physical selves became irrelevant. And humanity may be on the exact same path. The next challenge is not building faster engines or stronger spacecraft. It is engineering cognition, intelligence, and endurance. Artificial intelligence, mind uploading, self-replicating machines, these are not just science fiction anymore. They are the blueprint for the first truly interstellar explorers. And the thought is both exhilarating and sobering. We may reach the stars in ways our ancestors could never imagine, but we may arrive changed, unrecognizable, almost alien to ourselves. All the technology in the universe cannot answer the most profound question. What does it mean to be human when we leave the human body behind? We have imagined ourselves traveling to the stars, colonizing distant worlds, and exploring the far reaches of space. But in every scenario we've explored, whether mind uploading, autonomous AI probes, or self-replicating machines, the biological human does not travel. our flesh remains bound to Earth. Or, at best, our bodies endure limited journeys to Mars or beyond the solar system. Yet our minds, our consciousness, our very essence can venture where no human could survive. This presents a fundamental dilemma. Do we value the journey itself, the experience of traveling in a body under the stars, or do we value the knowledge, the expansion, the discovery, even if it comes at the cost of our biology? Philosophers, futurists, and scientists debate this constantly. Some argue that the biological experience is irreplaceable. The feeling of weightlessness, the sight of a sunrise from orbit, the pulse of life in an alien environment. These are experiences a machine cannot fully capture. Yet others insist that consciousness is what matters most. If we can preserve thought, memory, and awareness digitally, we can continue the journey in ways our bodies never could. We can explore galaxies, witness cosmic events, and survive timelines that far exceed the lifespan of any human. In essence, we may transcend biology, becoming something both human and beyond human. And there is precedent for this idea in nature itself. Humans have always extended themselves through tools. We crafted fire to survive the cold. We built wheels to travel farther. We built telescopes to see deeper. Machines and tools are the natural extension of our survival instinct. But now, the tools themselves may become the explorers, and we may become the information embedded within them. Some scientists suggest that this could be humanity's only chance to endure in the cosmos, because time is finite. Stars die, planets become uninhabitable, the universe continues expanding. Biological humans cannot last forever. Digital humans, or AI-human hybrids, can. This brings another dimension to our journey. If we choose to send machines or minds into space, we are also creating our legacy, not as physical colonists, not as flesh and blood conquerors, but as the first civilization capable of surviving cosmic timescales. There is, however, a tension in this vision. We are explorers and storytellers. The human experience is deeply tied to sensation, to risk, to emotion. Can a consciousness traveling through coded environments experience awe? Can it feel loneliness, or wonder, or joy? These are questions with no clear answers. And yet, despite all these uncertainties, the drive remains. Humanity will explore. We may never set foot on distant worlds, but our awareness will. We may never see alien skies, but our awareness will. And perhaps that is enough. The stars will be touched not by our hands, but by the echo of our minds, by the creations we leave behind. Machines, AI, uploaded consciousness, they are not replacements, they are extensions. They carry the essence of who we are into the darkness. And one day, long after Earth has changed or even disappeared, traces of humanity, our knowledge, our questions, our consciousness may drift through the galaxy, silent, patient, enduring. In the next segment, we will examine the ultimate limits of survival and travel, how far and how long humanity or our digital selves can realistically persist in a universe defined by time, distance, and entropy. At some point, every journey meets a boundary, not because of technology, not because of intelligence, but because of the universe itself. To understand how far humanity can truly travel, we must confront the final constraints: time, energy, and entropy. Even if we master fusion power, even if we build self-repairing spacecraft, even if we upload consciousness into machines that never age, the universe still imposes limits. The first limit is time. Stars do not burn forever. The sun will die in roughly 5 billion years. Other stars will follow. Eventually, the universe enters an era where star formation slows, then stops. No new energy sources are born. Civilizations, biological or digital, must survive on what already exists. This is not speculation, it is the natural trajectory of cosmic evolution. Which means humanity's future is not just about distance, but duration. How long can we persist? Some physicists believe advanced civilizations could stretch survival across trillions of years by migrating between stars, harvesting energy efficiently, and slowing internal processes to near stasis. Others believe entropy always wins. Not suddenly, not violently, but inevitably. The universe expands, energy disperses, temperature differences flatten, and eventually there is no usable energy left to power thought itself. This moment is known as heat death, a universe where nothing meaningful can happen anymore. If that future is unavoidable, then the question changes. It is no longer how far can we travel, it becomes how much meaning can we extract before the end. In that sense, exploration is not about reaching a destination, it is about experience density. Learning, understanding, witnessing. A digital civilization could slow its perception of time, experiencing millions of years as seconds, or speed it up, compressing entire cosmic eras into a single conscious narrative. In theory, one mind could experience the entire remaining lifespan of the universe. That is farther than any spacecraft could ever go. But there is another boundary, causality. Even if we travel at near light speed, information cannot move faster than light. As the universe expands, distant galaxies cross a threshold where they become permanently unreachable. Not because we lack speed, but because space itself stretches faster than we can traverse it. This creates a cosmic horizon. Everything beyond it is lost forever. Entire galaxies, each containing billions of stars, slip out of reach. Which means humanity's accessible universe is shrinking, not growing. The longer we wait, the less there is to explore. This adds urgency to the story. If humanity wants to spread, observe, or leave a lasting mark, there is a window of opportunity, and it is closing, slowly but permanently. This is why some scientists believe the ultimate mission of intelligence is not colonization, but preservation. Preserving knowledge, preserving history, preserving consciousness itself. Not forever, but for as long as physics allows. And maybe that's the true endpoint of human travel. Not a distant star system, not another galaxy, but the deepest possible understanding of reality before the lights go out. From cave paintings to spacecraft, from fire to fusion, from Earth to the edge of space-time, every step humanity has taken has been driven by the same force, curiosity. Not survival alone, not dominance, but the need to know. And that need does not disappear even when the universe grows cold. If one consciousness remains, biological, digital, or something else entirely, it will still ask questions. It will still look outward. It will still wonder how it all began. In that sense, humanity's journey through space is not measured in kilometers, it is measured in awareness. How much of the universe can know itself before it fades? Through us, the cosmos learned to see. Through us, it learned to ask. And through whatever comes after us, it may continue, briefly, quietly, but meaningfully. So how far can humanity really travel through space? Not as far as our imagination, not as far as science fiction promises, but far enough to matter. far enough to leave a trace, far enough that for a moment in cosmic time, the universe was not silent, it was aware. And that may be the greatest journey of all. If humanity's ultimate journey is not measured in kilometers, then it is measured in legacy. Every probe we launch, every satellite we orbit, every data stream we send beyond our solar system is a footprint in the cosmic sand. The Voyager spacecraft, small as they are, carry golden records filled with the story of Earth and its inhabitants. They drift through interstellar space, silent ambassadors of a species that once wondered about the stars. These are the first steps of our legacy. And legacy is not just physical, it is knowledge. The science we accumulate, the understanding we gain, the questions we formulate, they outlive generations. Each discovery acts like a ripple, expanding outward in time, affecting decisions decades, centuries, even millennia later. In that sense, the act of asking how far can we go is not just about propulsion or energy or biology. It is about impact. How far can our curiosity extend? How far can our comprehension of the cosmos grow? How far can a civilization leave its mark before entropy, time, or extinction claims us? Advanced civilizations may not be remembered by monuments or cities or empires. They may be remembered by signals, algorithms, or traces in the structure of space itself. This leads to a haunting thought. Perhaps the silence we perceive in the universe, the Fermi paradox, is not a lack of life, but a lack of legacy that can reach us. Other civilizations may exist or have existed, but their signals, their presence, their knowledge may be confined to horizons we cannot detect. Humanity's task, then, is not merely exploration, it is communication across time and space. To ensure that our existence, however brief in cosmic terms, leaves an echo. This echo could be in the form of probes, artificial intelligence, or the knowledge embedded in self-replicating machines. It could be stored in a distant satellite, drifting silently in a distant star system, waiting for someone or something to find it. The ambition is staggering. To exist across light years, to persist through centuries, to survive epochs in which planets die, stars burn out, and galaxies collide. And yet, despite the immensity, the challenge, and the isolation, the drive persists. Because the human spirit, whether biological, digital, or hybrid, does not surrender to scale. Curiosity, creativity, and consciousness are forces that transcend the vacuum of space. Even if we never personally reach the farthest stars, even if our descendants exist only as patterns of information in machines, the quest itself matters. The cosmic footprint we leave will tell a story, that a species arose on a small blue planet, that it looked outward, dared to wonder, and sought to understand, that it was aware even for a brief instant in a universe billions of years old. And that, perhaps, is the most profound journey of all. Because no matter how far we travel physically, the true voyage is one of consciousness, curiosity, and legacy. We may never reach every star. We may never colonize every galaxy. We may never survive the heat death of the universe. But through the act of exploration, through the probes, the AI, the knowledge, and the questions we send outward, we ensure that humanity's awareness becomes a part of the cosmos itself. And in that, we have already begun to travel farther than anyone ever imagined. As we look outward into the night sky, the question remains, how far can humanity really travel through space? It is a question that has no simple answer. Distance, technology, biology, and physics all place constraints. Yet within those constraints lies a story far greater than distance or speed. The story is about curiosity, about intelligence, about the drive to understand. It is a story of ambition, of risk, of imagination. Even when faced with impossible distances, even when confronted with lifespans that cannot match cosmic time, humanity has never stopped reaching. Our spacecraft drift into interstellar space. Our telescopes peer into the depths of distant galaxies. Our AI and autonomous probes explore regions of space no human could ever touch. And through all this, we expand, not just physically, but intellectually and spiritually. We learn, we question, we grow. And perhaps the ultimate realization is this: humanity's journey through space is defined not by the stars we reach, but by the awareness we carry. We may never physically touch Alpha Centauri, or a distant exoplanet, or the edge of the Milky Way, but our knowledge, our questions, and our consciousness can travel farther than anyone ever could. Every signal sent, every probe launched, every theory developed is a testament to human determination. It is proof that in a universe governed by immensity and limits, life, intelligence, and curiosity can leave an indelible mark. And perhaps this is the true measure of interstellar travel, not in light years or parsecs, but in the impact of awareness across the cosmos. Through us, the universe glimpses itself. Through our exploration, the cosmos becomes aware, even if only in small increments. And in that awareness lies hope, not the hope of conquering every star, but the hope that consciousness, curiosity, and the essence of humanity can endure. We are biological, fragile, and finite, yet our ideas, our creations, and our questions are not. They stretch outward, they persist, they echo across the darkness. And so the ultimate journey is not measured by distance or speed or technology. It is measured by how far human awareness can reach, by how much of the universe can see itself through us, by how long our questions, our curiosity, and our consciousness can persist before the lights of distant stars fade. In the end, the journey through space becomes a reflection of the journey within, of exploration, of understanding, and of the unrelenting desire to know. Humanity may never physically reach every corner of the cosmos. We may never colonize distant galaxies. But in asking these questions, in striving to explore, in pushing the boundaries of knowledge and imagination, we have already begun the greatest voyage of all. The universe is vast. Our bodies are small. Our lifespans are brief. But our curiosity, our consciousness, and our legacy can travel farther than anyone ever imagined. And in that journey, humanity becomes timeless.